The title of today is Velocity Control, and the subtitle is How to Calculate User Unit for Velocity Mode. Velocity Control mode has two kinds of modes. First, cyclic synchronous velocity and profile velocity mode. And the significant difference between CSV mode and the PV mode is the PDO update cycle. In CSV mode, the drive renews the target velocity at every PDO update cycle. However, in PV mode, the drive doesn't need PDO update. The drive generates the profile by itself. They are the diagrams for velocity control. The first one is for CSV mode, which needs the PDO update. And the second one is profile velocity. In this PV mode, as we have said in previous page, the drive generates the profile by itself, like this kind of profile. So to make this profile, we need some different parameters. For example, maximum profile velocity, this one can maximum, and the profile acceleration, this one, this part, and the profile deceleration can this. So related parameters are like this, from here to here, and these four parameters to generate profile in PV mode. So with that four kinds of parameters, we can make this kind of profile. The first, target velocity here, that means something like this. And in this example, number 2 is the target velocity. Regarding the unit, we are going to talk about in the next page. So let's see just the value. In this graph, the target velocity is 2, and maximum profile velocity here. So maximum profile velocity is this one. It limits the maximum velocity. If the system has a very high level of the acceleration or high level of deceleration, the instantaneous velocity can be very high or very low, more than the target velocity. So in this case, to prevent the unexpected damage about the equipment, we need to set the profile velocity. So next, the profile acceleration is this, and the profile deceleration is this. So this is the parameters for profile mode. So we have checked how to use the velocity control in the previous page. And as you know, these parameters are for velocity control mode. However, there is some confusing concept that we haven't talked yet, which is that is called the user unit. Actually, I believe that there are many customers who are familiar with the server systems. They will be familiar with this concept and the meaning of a user unit, and they are aware of, I believe that they are aware of how to calculate the user unit or what it means. However, I still believe that there are some customers who are not familiar with concept, because some customers are not familiar with the subsystem and especially with the RS McApion's subsystem. So today I'm going to explain what is a user unit in very simple way and how to calculate this, because the most of units in these chapters have user units. So I believe that we need to know what it is and how to calculate this. This is the kind of diagram to show you what the user unit means. So basically, user unit is the scaling unit which is defined by user. So in this case, I mean in the velocity control mode, it determines the value about the unit time. So by setting this value, the output in this case the velocity becomes very different, because this value is the output by the setting 1. However, 1000, this value is the output by the setting 2. But they have the same input. The only difference is the user unit setting value. And this value depends on the user preference for the system. And this is the very simple meaning of user unit. So in the profile velocity mode, you need to set the velocity with user unit. Not only for profile velocity mode, but also most of setting value has a user unit in L7NH drive. So for this process, you need to check the basic two values. First one is encoder resolution, so encoder pulse per revolution, and the second is target speed. And all you need to do is multiply them together. So encoder pulse per revolution and the target speed. So however, one thing you have to remember is that because we use the time unit, the second, as the unit time in this drive. So in this process, the unit conversion is required for unit RPM. So RPM should be changed revolution per sec. So let's input the value. So 52488, which is the encoder pulse per revolution, and the 3000, which is the target speed. But we have to change the unit. So minute should be converted to second. We need to divide 3000 by 60, so we can get this value. And the unit is the user unit per sec, and that means the velocity for the L7NH drive. Actually, the output for the input. However, if there is a gear ratio in your drive, I mean, if you have a set the gear ratio for your drive, you need to add a gear ratio for this process. So in this example, we have the same encoder pulse per revolution and the target speed, 3000 RPM and 54288 pulse. So let's see the formula here. Encoder pulse per revolution and the target speed from here to here, it is same. The only thing that is added is the shaft revolutions over motor revolutions, because we have a gear ratio, and that means in these parameters 6091 from these parameters we can check this value, motor revolutions 54288 and the shaft revolutions 20, and this value is just the example, so you can set any values depending on your system preference. So let's input these values in this formula. So encoder pulse per revolutions should be 54288, and 3000 and the 2 converse units from minutes to second, we need to input 60, and 20, which is shaft revolutions, and the 54288, which is motor revolutions. So by this process, we can get 10,000 user unit per sec. So in the previous page, we have checked how to calculate the velocity, but in this page, we are going to check how to calculate the acceleration. There are several things we have to check, but by checking this chart, you can find all information that we need. Let's see this chart. The vertical axis, that means velocity, and the horizontal axis, that means time, that has the second unit, and actually the slope of this graph means the acceleration. So we can recognize what is the target speed and what is the required time. So in this chart, the target speed is 10,000 RPM, and the required time to reach 10,000 RPM is 2 seconds. And another thing we have to know is just the encoder pulse per revolution, but we already know what it is. In this case, this value is also 54288, and the target speed, as we have checked in this chart, it would be 10,000 RPM, and the required time is 2 seconds. And they are all information we have to know in this step. So let's see the formula. Encoder pulse per revolution and the target acceleration. But we all know that the acceleration is the velocity which is divided the time. So it can be changed like this, but like the previous page, we have to change the unit, minutes, to second. So this one should be changed like this. So we input the values encode the pulse per revolution 5 to 4 to 8 here, and the velocity, that means the target speed, target velocity 1000, and to change the unit we have to divide this value with 60, and the time is just 2 seconds. So we can get this value, and then this is the acceleration value, which has a user unit. So we can set these all parameters, even if some parameters have a user unit value. Now we know what it is and how to calculate this.